Also, before we start, thank you for that one. We're going to what we call this one. We're going to have some house rules first, reminding everyone to what to do in our discussion today. Starting with, okay, I'm sharing the correct screen. Let me have that one. Okay. House rule number one, mute your microphones at all times. If possible, turn on your camera. Okay. Raise your hand if you have any questions or use the raise hands button. And please listen well. But there's an additional one in the house rules that I wanted to remind everyone. Okay. Kindly don't annotate on the screen unless otherwise you are told or you will ask to do so also. If you want to annotate or you have any questions, please raise your hand first and wait for me to acknowledge you. Okay, mute your microphones at all times. But if you want to say something again, just raise your hands. Okay, and wait for me to acknowledge you. Use the raise hand button and the reaction button, and then just wait for me to acknowledge you. If you have any question or if you're shy, also you can send to me direct message in the chat box. So that if you're shy to ask question, um, by raising your hands or saying something, you can use your what we call this one. You can use the what we call this one, the direct message in the chat box. Okay. So without further ado, I think everyone is here. I can see 34 names or 33 names in the chat box. So we'll be starting now and starting with the very first question today for primary 5. Find the value of 2011 times 199.9 minus 210 times uh, 1998 for this one. Okay, so with that one being said, let's try to see our answer for this question. Again, find the value of 211 times 199.9 minus 210 times 199.8. So here will be our solution, everyone. So for this one, we'll be doing a little bit of factoring. Okay, so for the case of the 2011 times 19.1, the 2011 could be break to be 2010 plus 1, right? Like that 1. And then we can distribute your 1999 to each one of them. So by distributing, your resulting equation will be 210 times 199.9 plus 199.9 times 1, that's 199.9. So that's what we did there. We expressed 2011 by that. Okay. Then after that one, we express also the 1998 to be the difference, or we express this one in such a way that that will become a difference of 210 or 199, 201. Wait. We can express your 199.8 in such a way that that's yes, Nathaniel? Any question? Five raise.
Sir, this isn't the question in number one for me po.
Oh, what level are you in?
Primary 5.
Uh, is it take note, this is the mock test, not the BBB final round review, because this is a different review. I think you thought it's a BBB final round review. This is the mock test review. So you need to base it in the mock test. Really follow. The BBB final round review will be later on for your level. But for this one, this is the mock test review for that one. Are we clear with that one, everyone? Okay, this is the mock test review. Okay, clear? Right. Okay, now we'll try to continue with that one right now. Yes, okay. So as you can see, your 2010, 198 could be expressed as 2001 minus 199.9. Okay, the 199.8, right? So as you can see, we can factor that one out. And as you can see, we can multiply or distribute the negative 2019 plus 1998. So as you can see, we'll be having, wait, okay, 0.1, 0.01. Okay, now after that one, because yes, everyone, may I ask again, one of the house rules that I said, no putting your, what we call this one, no annotation unless otherwise you ask to do so. So please no writing on the screen, and only me will be writing on the screen. Yes, Mr. I think your name is popping up. So if you will not follow that one, kindly will asking you later to not do what we call this one, annotate again as much as possible. So as you can see here, we have that expression now. We express 2011 to be 210 plus 1. Then we distributed the 119.8. For the case of what we call this one, for the case of 199.8, we express that one to be 199, or wait, let me check that one. Yeah, we express that one to be 100. The 199.8 is expressed. Who's making the chat? The check one. I think I can see your name, Mr. May request again not to annotate unless otherwise you ask to do so. Okay, so let's try to have that one. Let's try to continue. So as you can see, your 199.8 can be expressed as 200 or 199.9 plus or minus 0.1. Okay, so we distributed also the 2010 in between them. As you can, the result will be 2010 times 199.9 minus 201. Kasi 200, or because 2010 times 0.1 is 201. And then from that, as you can see, we can distribute the negative and the positive. So this will become plus for this, and this is plus or minus for that, and plus 201. Since we minus this one, we can cancel this two, and what will be left is 199.9 plus 201, or 400.9. Any question and clarification with that one, everyone? Yes? Marcus?
Uh, I'm kind of confused.
With which part?
Like, how does 199.8 um like change?
You can express that one. That's one technique. We can what we call do some breaking of addition. We can change it because as a technique for us to solve the question, especially for harder ones. Your 199.8 could be expressed as 199.9. We would try to express that one so that it will be common. As you can see, this is quite near to each other. Your 199.9 is equivalent to 199 point or 199.8 is equal to 199.9 minus 0.1. We change that one so that we can perform it and not do a very hard multiplication. And that's one technique. If ever you haven't known it yet, you can learn that one right now para mas mabilis, or we can solve it faster as much as possible, the solution. Because again, that's expressible and we can do that one. It's a little bit of an advanced algebra. It's a little bit algebra already, but we can do that one also in numbers. That's why we changed that one so that as you can see, we can eliminate this hard multiplication and then eventually it will become like this. Did I answer your question, Marcus? For that one?
Yes.
Okay. That's right. Okay. So hoping that you will learn the technique for easy solvings. Okay. If there's no question for that one, let's try to move forward to question number 2. Okay. How about this one? This is a little bit of a technique also. 120 1,227 squared minus 773 squared. If you want to write your answers, you can try to write your answers in the chat box for question. Okay. Again, try to write your answer for. Well, may I ask, what will be your answer for this question? Okay. Let's try to have that one. Do you have an answer for this? Okay, yes, very good. Some of you have an idea already how to solve for this one. Yes, Marius?
I think I think the answer is wait. I still have to multiply that.
Okay.
Yeah, that.
Okay, sige. Let's try. Okay. Let's try to check your answer. But there's a technique for this one here. Will be involving, sorry, the formula or a little bit of a formula having the a squared minus b squared. We call it a difference of two squares in algebra. So it's very good for learning it already as early as you. We can break out that one to be a plus b times a minus b. So basically, if you have 1,227 squared minus 773 squared, we can just break that one to be 1,227 plus the other one, 773, times 1,227 minus 773. That's the formula for that one. So as you can see, that will become 2,000 times 454, an easy multiplication. We can just multiply 2 to 454 and add the 3 zeros at the back. So that's 908,000 for this one. Okay, 908,000 for this one. Any question and clarification for this? Okay, any question and clarification for question number 2 before we move forward to number 3. Okay, but that's a technique for that. This is what we call the difference of two squares. So if you have the difference of two squares, we can break it out to a sum and difference of the square root of those numbers. Okay, I can see no question. Okay, let's try to move forward to question number 3 then. I'm hoping that is clear already. And tell me if I'm too fast in the discussion. Okay, but we have limited time. So I'm hoping that this one is a little bit easy. Okay, right. Okay, let's try to move forward to question number 2. Okay, number 3. Number 3. Yes? Okay, number 3. Let's try to check. Okay, oh, we have this equation. 1 is 1 times 1. 4 is 2 times 2. That's the squares actually. 1 or 1 squared. 4 is 2 squared or 2 times 2. 9 is 3 times 3. 16 is 4 times 4 or 4 squared and so on. Now, 1, 4, 9, 16, these numbers are perfect square numbers, we call it. That's why, again, your 1 is like 1 squared. Your 4 is 2 squared. Your 3 is 3 squared. Your 16 is 4 squared. Because when you square root, it means you multiply it to itself twice. Or, yeah, multiply it to itself twice. So what is the sum of all the perfect square numbers from 1 to 500? So how do we solve for that one? So having an idea of perfect square numbers will help us solve this one because as you can see, we will try to find first the highest perfect square number near 500. So how do we do that one? So first things first, one of the easy perfect squares, 20 squared. 20 squared is 400. So meaning we will know that's around 21, 22, 23. 24. I do like memorize for my case, so that's a technique. I do memorize perfect square of powers of 5, like 25 squared is 625. That 25 times 25. Then you can like approximate from that. So as you can see here, 22, so around maybe middle of those number. So we can check 23 if you like. Actually, the better one to check is the middle between 20 and 25, which is 23. So it's more than that. And as you can see, 22 squared will give us 484, meaning the numbers that we'll be adding is actually until 484. All the perfect squares will be 1, 4, 9, 16 for 5 squared until 484. That will be the addition of perfect square. But how did it come to this one? Okay, so there's actually a formula in the perfect square, or formula for the perfect square. So how do we solve for the formula for the perfect square? Yes, 3795. Let's try to check for that one. Again, you can send your answer as soon as present the answer. If you have an answer, you can send it. You can send it if you're shy to send your answer. You can actually send it in the chat box. So again, for this one, how did we get to this point? If you're adding perfect square, like 1 squared plus 2 squared plus 3 squared until until n squared, we can solve that one by multiplying or by having the formula n times n plus 1. Okay, let's try to use the variables. N times n plus 1 times 2n plus 1 divided by 6. So for this case, your n is 22 because your 484 is 22 squared. We'll be adding until a perfect square 22 squared. This is what we call addition, or the formula for adding perfect square numbers. So as you can see, we are until 22 squared. So your n is 22. So 22 times 22 23, 22 plus 1 is 23 times 2n. So 2 times 22 plus 1 divided by 6. So that's like 11, or we cancel out actually. For it to be simple, we cancel out here 2 with 22. That's why it became 11. Then we can cancel out 45 here in 3 to make it 15, because if you cancel out 2, there will be a 3 left. There will be 11 left here. So 11 times 23 times 45 divided by 3. So 45 divided by 3, that's 15. And then we multiply those numbers only. So we'll be getting 3,795. But let me double check that one. Okay, 11 times 23 times 45. Yeah, that will be, I don't know, 11 times 13 times 15. So yeah, that's 3,795. Yes, welcome for that one. You can learn, that is a formula. That's why we're here. Okay, for this. Any question again, clarification for that one before we move forward to our next problem. Okay, right. 500 is not a perfect square. No, it's not. It's not. We're adding the perfect square from 1 to 500, not adding, yeah, 1 to 500. So that means 1 squared plus 2 squared until the perfect square near 500. Okay, near 500. Not adding perfect squares, 1 squared, 2 squared until 500. Okay, so that's one thing. Okay, what is the sum of all the perfect square numbers from 1 to 500? So those are 1, 4, 9, 16 until 484 only. I'm hoping that is clear already. Okay, because we're going to question number 4. Question number 4. Okay, but yeah, you can send your answers for that one. Okay, again, if you have any answers for the next question, you can send your answers already. Okay, here, there is a book with 600 pages. Ming reads one more page more than the previous day. If he can finish reading this book within 16 days, how many pages he read on the last day? Okay, so how do we solve for this question exactly? So he wanted to finish the books in 16 days. But again, the initial given tells us that you can send your answers. Okay, you can send to everyone. You can send directly to me your answers. Initial answer for this one. Okay, so for this situation, how do we solve that one? So as you can see, 16 days. But the first days is like one more than the previous page. But on the last day, it will be like a different number, right? So how do we like solve for this one? No? So as you can see, what will be happening is that we are going to try to with 16 days. He can finish reading this book with 16 days. So that's the given question for that now, 16 days. So for that case, we are going to try to find out the numbers or the number that we'll be doing. We don't know exactly how many pages in the first book, okay? So to solve for this one, what we can do is, yes, why is it this chapter answers only once? Because it's flooding my chat box. I cannot see. Yes, don't spam the messages, please. Be- because and kindly mute yourself. I cannot see the proper questions later on if we'll be spamming the messages. So may I request everyone to just chat once. Okay? I don't want to name names, but again, kindly chat once so that I can see if ever there are questions and clarifications per number. Okay,
Can I
yeah.
ask?
Yes. If you have any
Can I
question,
see? Can I see again the third question?
the what again?
The third question.
Fifth or third?
Third.
Third question. Okay. Right. Okay. Why? Do you have any question on that one?
No, I just had to look again because I cannot see.
Okay. Right. Okay. Here we go with that one. But we need to go forward. Yes, Gabriel? Do you see it now?
Will the recording of this mock test be sent to our emails?
Yes, it will be.
Okay.
Yeah. Okay. Right. Okay. Is it done already, Mr. Or Miss? I'm not sure. I'm sorry. Dok Tam. Are we clear with this one? Number 3 already, because we're going forward to number 4 so that we can finish the questions in time as much as possible.
Okay, I finished.
Okay. Yes. Also the solution, I think there you go. Together with the solution. Okay. Because we're going with the next Fibonacci method. Yeah, we can. That's not all about Fibonacci, but we can do actually addition. This is just actually an addition method. Let's try to move forward for the next one. This is summation of perfect squares. Okay. For this one, we'll be doing, this is not Fibonacci. This is like arithmetic sequence only, because as you can see, one more page. So what can we do for that one, or what's the technique for this one here? So first things first, we can assume first that the first technique is we assume that we'll be doing what we call this one. We'll be doing one page per for the first page. So meaning second page will be having 2 pages, 3 pages, and then the last page will be 16. So the summation for that one, the formula, by the way, for that one, if you're adding 1 plus 2 plus 3 plus that until n, is actually equivalent to this, what we call a summation of consecutive numbers, okay, or arithmetic sequence to be exact. Summation of consecutive numbers or arithmetic sequence. So for that one, we can have the formula 1 plus 2 plus 3. Sorry for my handwriting, by the way. That's n times n plus 1 divided by 2. That's why it became 16 times 17 divided by 2. That's a formula for summation of consecutive number. So if we know, we assume that the first day, we have 1 page, second day, 2 pages, third day, 3 pages, and so on until 16. If that was the situation, we can only read 136 books. Now, we can only read 136 books. But as you can see, if we have that one, we will have, because 600 pages all in all, we'll be having 464 pages left. So again, we know that that will not be enough. So what will happen is that we're going to divide 464 by 16. That will become 29. And we'll be adding the 29 to each of the days. So because of that, we can say that the first day is 30, the second day is 29, because we divided this extra 464 by 16. So we added it in those days. So 30, we have 30, what we call this one? 31, then second page 32, and so on until 29 plus 16, the last day, because initially we had 16 in the last day, but there's an extra 29. So that's 45. So 30 to 45 days. To double check, you can use the formula again. If you're adding consecutive numbers, Yeah, that will be the case lang. But we'll be having a little bit of a longer time to solve for that one. But as you can see, we can actually add the first and the last. So a sub 1, there's a formula for that one. Adding the first and the last number, a sub 1 plus a sub n, we call it. The first one is the a sub 1. The last number is a sub n times the number of numbers we adding. So we know these are 16 days, so 16 numbers. So we add actually, if you'll try to check, that will be the case. 31 plus 44, 30 plus 45 will give us over 2 for that one. So if you'll do that one, kasi you'll be having a sum. 30 plus 45, that will become what? 75. Okay, 31 and 44, that's another 75 times 16 divided by 2. If you multiply that one, it will give us 600 pages. So it's correct. So meaning on the first day we'll have 30, on the last day is 45 pages. And that's the solution for that. You can also actually do this way if you like. But yeah, actually we can have that one as the number of pages for that matter. And that's the solution or the technique for this. Any question with number 4, everyone?
What is
Clarification.
the answer?
45 is the answer. And the last day, there are 45 pages because first page 30, second day, I mean 31, third day, 32 pages, fourth day, 33, then so on until on the 10th day, we have 45 pages. So the answer for this question is 45. Are we clear with that one, everyone? Yes, Marcus.
Where do you find 30?
I added, again, we had the 29 here extra. If the 464 extra days we divided by 16, so they're 29. So we added the 29 to we assume kasi initially that on day 1 we have 1. So 29 plus 1, because of those extra days, we added this extra pages per day. So that's why you get 30 because 1 plus 29 is 30. We distributed the 29, the extra 29.
Thank you.
Okay. Question clarification for that one. Okay. Yeah, okay. CK. If there's no question for that one, let's try to move forward to question number 5. Okay, question number 5. How about this one? Both A travels 120 kilometers and upstream, and meaning against the stream, and both B actually is that one. Wait lang. Let's try to go. Yes, I'm here. I'm it's a little bit of the connection that lost lang. Okay, now let's try to go with this one. How do we solve for this question? So both A travels at with an upstream within 2 hours, and then both B can travel it within 4 hours. Okay, I mean the upstream or downstream for 4 hours or together with the river. Upstream within 2 hours and returns within 4 hours. Okay, so that's the situation. And then I think it's the same path within 3 hours. How many hours more between the way back and forth? So as you can see, yeah, I think there should be a downstream. Upstream, downstream. Down with the stream. Okay. So actually, because it should be shorter, actually downstream. So I think this is like the other way around. It should be the 4 hours. This should be the 2 hours. Okay. Because if you have upstream, you're against the water, so it will be like longer time. So how do we like solve for this one? So first things first, we will be knowing, or we'll try to know how much is the speed of the water for this case. Because for this one here, you 120 divided by 2, that means that the speed going down with the stream is 60 kilometers because distance or speed is equal to, by the way, distance over time. I think you know this one already. Speed is distance over time. So 120 divided by 2 is the speed of the boat with the water. So that's 60 kilometers per hour, right? kph for this. And then we have the speed. This is for the downstream speed. So for the upstream speed, again, we have 120 because same distance divided by 4. So that will give us 30 kilometers per hour. So that is the speed of our, 30 kilometers per hour. So that is the speed actually of what we call this one. That is the speed of our that's the speed of the boat going downward. So as you can see here, there is, if you'll try to divide or subtract these two, that will be giving us 60 minus 30. That is actually 30 kilometers per hour. 30 and divided by 2, that will give us the speed of the water. So that's 15 kilometers per hour. If you subtract those two speeds, if you average or subtract the difference of the two, because the water is helping forward and the water is helping, or it's against downward. So if you subtract those two and divide it by 2, that will give us the speed of the water. So the speed of the water right now is 15 kilometers per hour. Like that. Okay, so because of that situation, we can actually solve the question here at hand. No? We can solve now the question here at hand because we know that the speed of the water is 15 kilometers per hour. So this is for both A right now. For both letter B, what will happen is that we can get within 3 hours upstream. So I mean that actually downstream, no? For that case, a shorter arc. So that will become like 13 or 120 divided by 3 hours. That means the speed downstream with the water, because the water is helping us downstream, that will give us 120 divided by 3. That's 40. That's 40. Okay? That's 40 kilometers per hour. Okay, now 40 is with the water speed. So we subtract this one out, and then trying to have that 140, we'll be subtracting this by 15, this 40, and it will give us a speed of what we call this one. It will give us the speed of the boat in still water if it's not being held by the stream. So like that one, so 15 for that matter. So that means that will give us, wait now, let me double check. That will give us 25, 12, 120, 12, 25, 25, That will give us 25, wait. 15, 30, 40, and that will be the case, yes. Yeah, we'll try to see if we'll be having a break, but usually after 1 hour for that case. So 40 minus 15, that will give us 35 or 25 kilometers per hour. Okay, that's 25 kilometers per hour. That is right now the speed of your, what we call this one, the speed of your boat right now at still water. Okay, so because it's being helped right now by the water. Now, because of that, the 25 kilometers per hour, this is your boat speed. So we can subtract this one farther by 15, and we will see that because of that one right now, we can find the speed of the boat downstream. Okay, so we subtract this one. Why will we subtract 15 again? So 25 minus 15, that will give us actually, what we call this one? This is the speed of the water minus 15 right now. That will give us another 10 kilometers. So as you can see, 120 divided by 10, that's become equivalent to, because again, for this case, we'll try to find out the time, and time is equal to distance over speed. So again, this is the speed of the water upstream, or downstream, I mean, together with the water. So when we subtract this one, 25 minus 15, because that's the speed of the water, upstream it will be subtracting the speed of the boat will be subtracted if you're against the stream. So you'll have 10 kilometers per hour if you're going back right now. So meaning from that, your distance 120 divided by 10, it will give us 12 hours going backward. Okay, going back. So 3 hours forward, 12 hours backward. So 12 minus 3, it will give us the final answer to be 9 hours. So the correct answer for this question is actually 9 hours. Any question and clarification for that? Okay, we will have 9 hours actually way forward and backward. But again, this is the upstream downstream problem. Any question with this one, everyone? Before you move forward to question number 6.
Why do you minus 3?
Why do we minus 3? Because 3 hours is it says there 3 hours forward, so we'll be actually trying to go back what we call this one. We're going to try to go backward. So we're trying to ask where it's asking actually us how many hours between going forward and backward. So we learned 12 hours is going forward. Then way back is 3 hours a while ago. So therefore we have 9 hours. Did I answer the question? Yes, Kaden?
Mister, for the
Yes.
one at the part B1, I don't
Yeah.
really understand still.
Which part? Exactly. Which part exactly, Kaden?
Um, uh, I don't, I don't understand. Why is it 40 minus 15?
Why is it 40 minus 15? Because again, if you're moving together with the water, imagine your boat. So as you can see in the river, the boat is moving. Okay, there's a speed for the boat like that. Oh, so sorry for my drawing of the boat, but the water is also moving, so it's pushing the boat. So here, because it's together with the movement, the 40 kilometers per hour here is the movement of the boat together with the river, right? So we wanted to know what's the speed of the boat only. So we know that the speed of the
Oh,
water is 15 already. So we subtract the 40 because it's the speed of the boat with the water. So we subtract the 15 to get the speed of the water. I mean the boat only. So this is actually the speed of the boat only, the 25. And
also that
because
means the 25 is the water and the boat, and then so we
no,
minus
no, no. The
15.
40 is the water in the boat. The 25 is the boat only. So we subtracted the 40 by 15 to get the 25. Did I answer the question?
Okay, thank you.
Yes, welcome. So then after that one, that will be the case. Yes, Mr. Um, yes, I think that is actually I did explain that one. The word here should be downstream. This is typographical error. Yeah, if you use upstream, that will be the answer. Pan Kwang Tuan, yes. But I think this is this is like what we call this one. What we call this. It's like typographical error because it's quite obvious. Because if it's upstream, it's impossible to be shorter upstream. It should be shorter downstream. Okay, so this is actually downstream also. This is typographical. That's not upstream, it's downstream. Did I answer that one, Pan Kwang Tan? I think there's a typographical error that should be downstream for that to coincide with the solution, actually. Okay. I'll reiterate that one. Pan Kwang Tuan. But yeah, if you have that one, that will become because you cannot get the 25 if that's the case. If that is the upstream. So that should be downstream, and should be the answer. Did they answer the questions for this one? It's a little bit challenging, the speed problem, most of the time. Okay. So again, any question for this? Clarification. Okay. Okay, right. If there's no question for that one, let's try to move forward to the next number. Find the value of 40's cube. Yeah. Okay. Yeah. Pang Kwan Tuan. Okay, let's try to answer that question first. Why did I subtract 15 twice, right? So first things first, let's try to do that one. We subtracted 15 twice because here, the first 15 is to find the both, and the second 15 is to find that speed. Because upstream, I mean, if you're against the water, your the speed of the water will subtract the speed of the boat. That's why we subtracted again 15 to know the speed of the boat going against now because there's 25 kilometers, but the water is holding you back minus by 10. So there minus by another 15. Now, if we find the 25 for the speed of the boat, but again, you're going against now with the water. So you'll be having to subtract another 15. Did I answer your question? Pan Quang Tuan, before we move forward to question number 6.
Yes.
Okay, right. If that's a yes, let's try to move forward. Okay, let's try to move forward with this next question. How about this one? You can try to check your answer for this. Let's try to understand and send your answer. Okay, let's try to move forward to this question. How do we solve for this one? Okay, sige. Let's try to check for the number 6. How do we solve for that one? So we'll be having 40 cube plus 39 cube plus 38 cube until 10 cube. So for this question, we need to know the formula actually of the summation of perfect cube. So this is a solution for this. How do we solve for that one? So from 40 cube to 10 cube is actually like subtracting 40 cube to 1 cube. We're adding 40 cube to 1 cube, perfect cube numbers. And because there's a missing 1 to 9 here, the 9 to cube to 1 cube, we'll be subtracting 9 cube to 1 cube. Why did we have that one? Because we do have a formula for the summation of perfect cube. If we're adding 1 cube plus 2 cube plus 3 cube plus that until n cube, that will give us what we call this one. N, the formula is n times n plus 1 over 2 quantity squared. Okay, that's a summation of perfect cube. 1 cube, 2 cube, plus 3 cube until n cube is equivalent to n times n plus 1 quantity squared. I forgot the square. That's why, as you can see, from 1 cube to 40 cube, that will become 40 times 41, n times n plus 1 divided by 2, quantity squared. And then 1 from 1 to 9, that's 9 times 10 divided by 2, quantity squared. And that will give us 820 squared minus 45 squared. Then we can apply the formula a while ago, a squared minus b squared, which is equivalent to a plus b times a minus b. There's a technique here. So that's a plus b, 865, 820 minus 45, that's 775, and then that's what we're going to multiply to get the answer, 670, 375. And that's the answer to our question. Do we follow for that one? Any question and clarification with the solution? Okay, question for that one, clarification? Okay, let's try to move forward with the next one. Okay. Okay, sige. So for this one here, let's try to move forward to question. I think no question for that. Everything is clear for that number. Let's try to go to question number 7. Okay, question number 7. Yes. Yes, so that's why you have learning it one right now. It's a little bit advanced, but yeah, sometimes the questions are having this one already from your level. So it's a little bit advanced for your level, maybe. It's actually learned in high school already, but since you're joining international competitions like this one, it's very good technique for you to learn those formulas as early as this because it's going out already in your level. Okay, in your level for international competition, maybe in school level and school level not, but in the international competition, it's already going out. So it's good for you to learn that one already. Okay. In your school level, maybe there's a little bit of a longer solution. That's why we're learning the shorter ones, but we need to understand also that one. I'm hoping you're understanding the formulas here. Okay, so right. Let's try to go with number 7. Now there are 7 different natural numbers. Their sum is 2009. What is the maximum value of the highest common factor of the 7 natural numbers? So how do we solve for this one? Okay, their sum is 2009. Okay, so we're trying to find here highest common factor of the 7 natural numbers. Okay, so we have 7 different natural numbers. Their sum is 2009, right? What is the maximum value of the highest common factor of these 7 natural numbers? So what can we have for that one, right? So how do we solve for this question exactly? No? How do we solve what's the maximum highest common factor of these numbers that will have a sum of 2009? The sum was 2009. So right, okay, different natural numbers whose sum is 2009. Wait, now there are 7 different natural numbers, okay, and the maximum value of the highest common factor of these natural numbers, HCF will be highest common factor or GCF, greatest common factor. So what is the greatest common factors for that one? How do we solve for this situation? So first things first, we need to know there's sum of, okay, 2000. So basically what will we do for this one is just actually, wait lang, 7 different natural numbers. Their sum is 2009. Okay, their sum is 2009. What is the highest common factor of the 7 natural numbers? So that's what is asked in this question. So first things first, we'll try to prime factorize your 2009. And that's 7 times 7 times 41. 7 times 7 times 41. So we wanted to add up these numbers. And using that one, we can see that the prime factors of 2009 is 1. Because of this prime factorization, we can find the factors of your 2009 by combining each of them. So like 1 times 2009, 7 times 187, 28 times 49, and 41. Okay, Mr. Leroy, can you please stop annotating on the screen, please? So that will be the case for that, no? That will be the case. So these are like the factors or the numbers that we'll be having, right? I mean, these are the possible product or numbers. Why did we use product, by the way? Because we wanted to know the greatest common factor. So 1 times 2009, 7 times 2087, 28 times 49, those are the numbers that we'll be having to multiply, or 49 times 41, 28 times 27, 287. So these are like the factors of the factors of 2009, right? The factors of 2009. So as you can see, we're trying to find the highest number that could be the greatest common factors among them. So if we'll be using 2009 as one of them, that will be quite big, because the only number, we cannot add anything after that. If we'll be using 287 or multiples of 287, that will become like very big, right? Did we miss something in the 2009 factors? Wait, now let me check. We'll try to check if we missed something. 2009 divided by 7. Okay, that will give us 287. 2009 divided by 49. That is 41. Okay, so these are like pairs of, again, these are pairs of product of numbers. Okay, 41, 28. Okay, I forget the 28. No, the 28 here is the sum of 1 to 27. So 28 is in between them. So we know that if we add 1 to 7, if we'll be using numbers from 1 to 7, that will become 28. So as you can see, if we'll be using 287, that will be quite of a big number to add that one up. So as you can see, if we divide 2009 by, because the 28 is like a factor of 7 times 4, like that one, so we can actually just multiply them by actually 7 and then try to create those numbers that will have like 49. So we can actually use 49 as the greatest common factors of those numbers, because 287 is not a possible one. Because for it to be a greatest common factor or highest common factor, it should be one of the factors of 2009. So the one that we can use only here is 49. 49 for that one. And that's the answer to our question. Any question and clarification for number 7 as we go along to question number 10? Clear for this one, everyone? Okay. Yeah, if that is clear, let's try to move forward to question number 8. Let's try to have this one. 6, 1, 2, 3, 4. So 5, 6, 1, 2, 3, 4, and so on, divided by 37. What will be the answer for this one? So the solution for this is this. Okay. If you look at that one, everyone, actually, the numbers here are just rearrangement of 1, 2, 3, 4, 5, 6. So if we add them out, it will be like for the first one, there's a sum of 5, 4, 3, 2, 1. Or every place value, it will be adding 1 to 6. Every place value is like that one. Okay, then after that one, the sum of that is like 21. So that will become like 21 per place values. And because of that, we can actually like express that one in such a way na if we have that kind of scenarios that all of the numbers is the revolution of 1, 2, 3, 4, 5, 6, we can express that one to be 1, 2, 3, 4, 5, 6 times 1, 1, 1, 1, 1. 6 numbers multiplied to 21. How did we have that one? Basically, because in the first digit, okay, let's try to show lang how did we get that one. So the first digit is 1, 2, 3, 4, 5, 6. In the ones digit. So that's 21 in the ones digit to show. Plus, in the tens digit, that's the sum of the digits in the tens is 21. So 21 times 10. And the hundreds digit, that's 21 times 100. In the tens digit, because it's all 1, 2, 3, 4, 5, 6. In the thousands, 21 times 1,000. Because in the thousands digit, then 21 times 10,000. Sorry for my handwriting. Okay, let's try to change that one into additional, sorry, for that one. So the first 21 times 10,000, 100,000 for the hundreds digit, plus 21 times, or 21 plus times what 10,000, because in the thousands digit, if we add those numbers, 10,000 digit is all add up to 21, plus 21 times 1,000, plus 21 times 100, plus 21 times 21. So 10, and then the ones digit, that's 21, or times 1, we'll put times 1. As you can see, we can factor out the 21 there. If you factor out the 21, That will be 21 times the sum of 1,000, 100, 100,000, 110,000, 1,110, and 1, which is 1, 1, 1, 1, 1, 1. That's why we have this. 21 times 1, 1, 1, 1. So the 1111 is divisible by 37 actually. That's 3003. So that's 21 times 3003. That will be the answer for question number 8. And that's why we have that answer, 63063. Okay. Any question with that one? Clarification.
Can I see again the answer of question 7? I just got kicked out.
Okay, wait. Why is it 21 again? Because again, what's the sum from 1 to 6? Mr. Okay, it's a direct message. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. Because again, if you look at the digits, every place value is just addition of 1 to 6. Okay, this is like rearrangement of that one. For that, the one that chatted, Mr. Leroy. I don't know. Nathaniel, did I answer your question? Yes, Kaden. Any question, Kaden? For that one?
Question 7.
Yes, Pom Duktam, if you'll be having any question for 7, we need to, what we call this one, try to check the lang because if we'll be going back and forth, we will not finish everything. So try to check the video later on that will be sending for that one to go back for number 7. We need to move forward to number 9 right now, okay? Because we will not finish in 2 hours later on for that one. Okay. Okay. Yes.
Mister,
Yes, Kaden.
I still don't understand this part. The one that says 1 plus 2 plus 3 plus 4 plus 5 plus 6 and then times 111,111.
This one
Actually,
here. This is the explanation for that one. Because again, as you can see that the ones digit 5 plus 4 plus 2 plus 3 plus 1 plus 6. If you look at and study the pattern, every unit's, every place value is just 1 plus 2 plus 3 plus 4 plus 5 plus 6. So if you added the ones digit, it's all 1 plus 2 plus 3 plus 4 plus 6. That's 21, right? That's a 21 here. Right. So in the ones digit, that's 21 times the ones digit. If you study the tens digit, that's the same thing because the numbers here are rearrangement of 1 to 6. So the tens digit are also 1 plus 2 plus 3 plus 4 plus 5 plus 6 times 10. And every place value are 21 or 1 plus 2 plus 3 plus 5 plus 6. Then we factor out the 21 outside. What will be left is 100,000 plus 110,000 plus 1,000 and so on. That's the 111. So that's like 21 times 111. This is the explanation of that. Do we understand that one now? For that case. Yes. We'll try to have it move forward for that one. Jayden, any question for that one? Clarification. This is expected for the mock test because this is for everyone that way. So we'll on the mock test, usually we finish what we can finish in the mock test. Okay, right now, let's try to move forward to question number 9 then. Okay, so that we can finish this one by 10 o'clock. Okay, let's try to go to question number 9. There are 13 cards and 2 main shirt pockets. Each number is 1 to 13. If he chooses one card from each pocket, then he counts the product of these 2 number cards to get the different products. How many products that can be divisible by 8? And that one. Yes, Jayden? But if you have do you have any questions, Jayden? So far, understand everything for that case? Yes, we'll be continuing with that one. Again, it's expected for the what we call this one for the mock because we're trying to explain everything as much as possible. Okay, for you to understand. Jaden, any questions so far? Okay, Sige, if there's any question, let's try to move forward from this number. Okay, there are 13 cards. Okay, let's try to have this one. There are 13 cards. I'm so sorry. I think I closed the PowerPoint. Okay, let me have it that one again. Okay. For question number 9 for that one. I'll try to finish that one right now. So let's try to go to question number 9. Question number 9. Question number 9. Here we go. So the question is 13 cards are in Ming's hand. Okay. 13 cards are in Ming's hand. I'm hoping you can see the screen right now. Okay. So there we go. Let me share it properly. So each number cards is written 1 to 13. If he chooses a 1 card in each pocket, then it counts the product of these two numbers to get different products. How many products can be divisible by 8? So for this one here, we are going to know how many numbers are divisible by 8 for this one. So to solve for that, we are just going to identify divisible by 8 among those numbers. How many choices do we have for that? So your 8, the factors of 8 will be like 2. 8 is like 8 is in the prime factorization is 2 times 2 times 2, like that. 2 times 2 times 2. So from that, among the choices that we have to combine them to make that is either 2 times 4, or we're going to have the possible numbers 12, 10, 12, 2. Okay, we're going to like have that one that are possible numbers that we can pair to create those numbers to be exact. Okay, so how many are those? So basically we'll have like 2, or let's try to check. We'll try to go with the highest number, so 12. So you're 12 because 12 has a factor of 4 times 3. So meaning we just need to pair them up. The 12 should be paired to all even numbers. No, all even numbers, so that we can create we need to pair a 2. So that means that all even numbers. So the 12 will be paired from 12 to 2. Okay, I think the solution is quite missing here. Okay, 12 to 2. So therefore that's 12. So in 12 there are 5 numbers that we can pair it. The numbers 10 to 2, right? Again, the 5 numbers are 10, 8, 6, 4, and 2. So that's 5 ways. For the case of 10, because 10 has a factor, or what we call this one, because the 10 is like have the 2, we need to pair the 10 to factors that are divisible by 4, right? Divisible by what we call this one. I mean, we need to pair that one up right now with those numbers that are what we call this one, that are multiples of 4 less than 10. We cannot pair that one already to 12 already here because we counted that one already. Okay, with each number cards in the pockets, 2 different products. Wait. How did it count the product of these 2 number cards and get different? If just 1 card from each pocket, okay, 1 to 13. Okay, so we can pair that one out. Okay, so for that case, I think we can also pair yes, any question? Can you mute yourself? Let me double check for that one. The given states that 1 to 13 and 2 main shared pocket respectively. Each number is written from 1 to 13 if it chooses 1 card from each pocket. Okay, of these cards to get different products. Oh, different products for that case. So we need to create different products. So basically, we wanted to create different products for this one. Okay, so 12 and so on. 12 times 8 and 2. So how many different products for that case? So we'll try to pair them up. Yes. Yeah, we're not yet done for that one. We will try to pair again. How many products that can be divisible by 8 are there? So we're trying to find how many numbers we can actually create for that one. So to make it simple, okay, to make it simple again, you're 8 because if you have an 8, if you choose an 8, we have 13 ways for the case of 8, right? 1 times 8, 2 times 8, 3 times 8, 13 times 8. So there are 13 ways. So try to focus on this one here. Okay, now, for it to be simpler for us to see. So as you can see here, if we have 8, we can have in one hand 8, and each pair of 8 with the numbers will become 13. I mean, 8 times 1, 8 times 2. So there are 13 ways for that one. 8 times 1, because if you multiply that, for a number to be divisible by 8, 1 should be 8. So 8 1, 8 2, 8 3 until 8 13. That's a combination of the cards. One card is 8, the other card is 1 to 13. So there are 13 ways for that, for this situation. Here, then the next one is that actually the one higher than 8. Because after that one, if you look at that one, 8 times 13, 8 times 13 will give us what? 8 times 13 will give us 104. 104. So basically, after we have already here the multiples of 8 from 8 times 1 to 8 times 13. That's 104. Starting with 8 to 104. 8, 16, so on until 104. So there are 13 ways. If we get one card to be 8 and you get either 1 to 13, so that's 13 ways. Then, because we can try to see the combination of 12 right now, because that will become like bigger than 104. So if we'll try to have 12 times 10 and 12 times 12, it will give us the multiples of 8, that is 120. And then 12 times 12, that is 144. 120 is divisible by 8. 144 is divisible by 8. So those are actually the 15. 15. So the correct answer for this number 9 is actually 15. Did I answer your question, everyone? My question and clarification for that one. Yes, so that's it. Mr. Anonymous understood for that one. So that's the solution for that. That's why we get 15 for this question. Okay, right. As we go along, let's try to move forward with the next one. Okay, because we don't have enough time. Yeah, 4 times 2 is also 8, right? Right. But it says there in the previous question, it should be a different product. So the 4 times 2 is already counted in the 8 times 1 here. Because we're trying to find the different products, the product itself. So the 4 times 2 is still 8. So we'll be counting the product 8 as ones only. So that's why
that
there's
means if like RD like 8 times 1 is already 8. If 4 times 2 equals to 8, you cannot
yes.
use it again.
Because the key there is different products. So we'll
Okay.
just be counting those products as one. So the 4 times 2 case is another 8, which is already we counted here. That's why we counted it by 8. Yes, Marcus?
Okay, thank
May I go to the washroom?
Yes, you may. Yes, you may. Yes, who is other? Marius, yes?
How do I say this?
Yep.
If you choose this one. Wait,
Yeah.
if you already choose
Because different again, the key is
But if you
different
already choose one
products.
card 8, then there's another 8, right?
Yes, 64. Yeah, you can have that one. You can have another 64, 8 times 8. But the point is different products. So basically, we're trying to find the all the possible multiples of 8 that we can create if you have 1 to 13 and 1 to 13, pair them up. So we have like all the multiples of 8 from 1 to 13, which is until 8, 16, 30, 8, 16, 24, 32 until 104. But we don't until that. But as you can see, if we have the 12, we can combine it to 10 and 12 pa so that we can get 120 and 144. We don't have 112. It's not possible to get. And then we don't have 128 and then 130. 128 and plus 12 plus 8, 136. We don't have that one. So we have those numbers, and that's why the answer is actually 15. Hoping that's understood for that number 9, because we're going to move forward to number 10 question here. A group of 10 students in the hotel buffet together. If each student pays $180 and then 510 will be in luck. If each student pays 1,830, 330 will be remaining. So basically for this one, it's a little bit of an algebra. So 1,800 times the number of students, let's say n, there will be a lacking of 510. So we need the money should be having 510 more, okay, because it's less than the value that we wanted to have. This is equivalent to 1,830. If each pay 1,830 times the number of students plus 309 minus 390, because there will be an extra 390. So this one is the formula for the cost of the buffet. So 1,800 times n plus 510, because you lock 510, so you need to add 510. This is the cost of the food right now. So it's equivalent to 1,830 minus 390. So the solution for this one is actually, as you can see, this is a little bit of an algebra, okay? Actually the solution is algebra expressed mathematically. So we can transpose or subtract 1,800 here and minus 1,800 and okay, it's as much as possible. Learning algebra as firm level is very important already. So it's 510 is equal to 30n, 1,830n, that's 30n, minus 390, like that. Then we can add both sides by 390. Okay, sorry for that one, my handwriting. 390 plus 390. As you can see, what will give us 30n is equal to 510, like that one. 30n is equal to 510. I know, sorry. 390 plus 510, that's 900. So to solve for your n, you just divide both sides by 30, divide both sides by 30. It will give us n to be 30. So there are 30 students. It's a little bit of an algebra, but applying the concept. Each of the students pays 180,000. You need to have 510 more. If you pay 1,830, there's an extra 390. So the total value for the cost will be that one. That's your cost. And yeah, that's the answer to our question. Question and clarification for this one. We will not be having break time already. We'll try to continue so that we can finish it out. Okay, if we have extra time, because we cannot have break time anymore, we'll be finishing your all of this as much as possible by 11. Okay. Yeah. If you want to go to break time, you can eat while you're having your food there. Just continue listening. You can have your food with you. If you want to go to the CR, just go to the CR. Because we'll be trying to finish all of this. Because if we will try to have a break, we might end at 12 o'clock already. Okay. Shall we move forward? Any questions so far with this one? Clarification, everyone. Okay. Sige. Okay. Okay, let's try to move forward with the next one. Okay, next question. Question number 11. Okay, question number 11. How about this one? If 11-digit number 1, 2, 3, 4, 5, 6, 7, 8, 9, blank, blank can be divisible by 36, what is the maximum value of the number in the boxes? Okay, what's the maximum value of the number in the boxes? So as you can see for this one, the maximum value, again, may I ask everyone to mute themselves? The maximum value of the boxes is, how do we solve for that one? No, so for this case, so we need to know how much is the value. We need to know that it's divisible by 36. So for it to be divisible by 36, this is what will we do? We try to prime factor the last two digit. Okay, I mean the divisibility. So that's 9, and that is 4. 36 is 9 times 4. That's like 3 squared, or that's 2 squared times 3 squared, like that. Why did we do prime factorization? So that we know what are the divisibility rules that we'll be using. So because the prime factors of 36 is 2 squared times 3 squared, meaning we need to use the divisibility rule of 4 and 9. That's how you'll identify what divisibility rule will you use because of the prime factorization, right? The prime factorization. So the prime factors of 36 is 4 and 9, right? 4 and 9. So we'll be using the divisibility rule of 4. So for it to be 9, we know that the divisibility rule of 9 is that the sum of the digits should be divisible by 9. So we add 1 to 9, that's 45. So meaning the last two blanks should add up to a number divisible by 9. Either 9 or 18 or 27 or 36 and so on. Meaning those are the possible numbers for that one. 36, then 45, and so on. Okay, as you can see, but divisibility rule of 4. So according to 4, the last two digit should be divisible by 4. That's the divisibility rule of 4. Again, yes, Mr. Yuan? Any question with that? Yuan Poyo, the one raising hand, yes? Any question? Again. No, okay, sige. Again, kindly mute yourselves, everyone. So again, prime factorization will be applying divisibility rule of 9. So actually you can see again, it's divisible by 9 for that matter. And then 4. So the last divisibility rule of 4 is that the last two digits of the number should be divisible by 4. So meaning because of that, the choices for the last two numbers either we have 36, and 45, 54. No, 54 is not divisible by 4. What's the next one? Because for the case of the 9, using the 9, these are the numbers 45, 54. We have what? After 54 plus 9, 63, 72. So we have either 72 also is possible. 72 because the last digit is divisible by 9. Divisible by 36. 72 plus 9, 81, and then 90. So those are the possible cases only for the last two digits, or 09 for that case. So we're trying to find, but here, because of the divisibility rule of 4, 36 is 9 times 3. So we'll have either 36 or 72. So that should be the answer for this question is, what is the maximum value of the number in the boxes provided? So that should be, actually we can have 72 also. So that should be 7, not 6 for this question. I don't know, it's either, wait, what is the maximum value of the number in the boxes? So I think the correct answer here is 72. Because the number, yeah, wait. So it should be 7. Because 72 is a possible scenario for that one. 72, having the last two digit to be 72 for that. So yeah, that's it. 72 is a possible value for that. That should be the correction for that one, yes. 72 is divisible by 36, yes. So that should be 7. Okay, the maximum number there is 7. Yes. Any question for that one? Clarification. 72. But if you're asked about each digit, then that's 7. If you're asked about the whole number, then the maximum number should be 72 because it's either 36 or 72 will be on those boxes. Question clarification for that one, everyone. Okay, if there's no question, let's try to move forward with the next one. Okay, for this. Okay. Let's try to move forward to question number 12 for that case. Okay, question number 12. This one is usually going out in the questions. You cannot step in those zero paths. So how do we do this one? So here's the solution for this. We'll be starting actually with here in the point A. So going to this 6 direction, that's one way. Going up, this actually should be 1 also here. So going to the right, this is how we fill up this boxes. We cannot go on those 0 here, right? These are the zeros here a while ago. So we cannot go on those lines. So we cut it here in the solution. So this is how we solve that one. So going to the right first, we started with A. There should be 1 unit here in A also. So going to this point, because you either go up or go to the right only, there's one way. Going here, that's one way again. One way, one way, one way, because it's only from the left side going to the right on that side. So here, actually you can see we are actually filling up this one by row. So that's the first row. Then the second row, there's only one way going to this point because it's from down. But here it will become 2 because we'll be adding this 2. From the left and from down, it will add up to 2. So the number of ways we'll be adding it. Here, 2 plus 1, that's 3. 3 plus 1, that's 4. 4 plus 1, that's 5. 5 plus 1, that's 6. And 6 plus 1, that's 7. And that's the process all throughout. Okay, going out, that's 1 only. 1 plus 2, that's 3. 3 plus 3, that's 6. 4 plus 6 plus 4, that's 10. 10 plus 5, that's 15. 10 plus 6 is 21. Then 21 plus 7, that's 28. That's what we're going to do all throughout. But take note that if it's connected on D, because here it's only connected to 1, so this 1. But the 4 here is connected to 1 and 1 and 3. So that's why we have 4, 4 and 10, 10 and 10, 20 plus 15, that's 35. Here, and this point, each of the point will be like identified. So this is 35 only because there's no going up here. There's no line. So that's why it became 35 only here. And then 35 plus 28 will be having 63. So those missing parts will create some not continuation, okay? Or sometimes it will be like 1 connected to those points. As you can see, same way here in the next page. But again, for us not to be confused, it's better for us to do it by a row. So example here, 1. So 1 plus 4, 5. 4 plus 5, 5 plus 10 is 15. 10 plus 20, that's 35. No going here. So therefore, it will be like from this one, it will become 35 only. 35 plus 35, that's 70. 70 plus 63, that's 133. And again, the same pattern as we go until we finish it up. So 1 plus 5, there's no going here. So that's only 15 going up. 15 plus 35, that's 50. 50 plus 35, 85. 85 plus 70, 155. 155 plus 133, that's 228. So again, that's a process here. I think this one is complete now. This one is 22. Again, the arrow is going up, going here, going there. So that's 72 plus 185, that's 157. Here and here, that's 312. And 312 plus 288, that will give us 600. And that's a solution for that problem number 12. Any question and clarification with that one? Yeah, the correct answer is 600 for this. Again, any question and clarification for that one, everyone, before we move forward to our next problem? Any question and clarification? Okay, if there's none, yeah, it will be compiled. So it might be one of these days, not exactly today or tomorrow. If they can finish it today, then they will be sending it today. Okay, let's try to see. Let's try to see. Okay. Now let's try to move forward. Yes, yes, because you cannot pass through it. Yes, that's correct. Because you cannot pass through it based on the given. Yeah, we erase it so that it will be easier. But if you refer its original figure, but that's actually better to erase that one because you cannot pass by there, the O. The one that the removed lines there is the O part. Okay, the one that is being removed here. Basically, here is the O. Here also is the O, and the other one, O, is here. Okay, I'm hoping that that's answered already. Okay, right. Let's try to move forward to the next question. Question number. Let's try to move forward to question number 15. Okay, let's try to have this one. So how do we solve for this question? Okay, so for this question, we'll be breaking. This is a little bit of a breaking out, okay, of the situation. If you look at the pattern, the 5 plus 6, or the solution for this one, before we go to that point, is that the 5 over 6 is actually equivalent to 2 plus 3 over 2 minus 3, 2 times 3. Okay, which is actually we can break out to be 1/2 plus 1/3. Okay, because we cross multiply, right? If you know the technique, some of you will do the technique like cross multiply 2 times 3. So your 5 is 2 plus 3 over 2 times 3. We can break that one to be 1/2 plus 1/3. That's why the 5, 6 here become 1/2 plus 1/3. Similarly to 7 over 12, that is equivalent to 3 plus 4 over 3 times 4. So that's basically 3 times 4. That's basically equivalent to 1/3 plus 1/4. Because again, when we simplify LCM, we multiply, and then 4 times over 12, so on and so forth. And all of the rest will be following that pattern. That's why we'll be having, again, everyone, don't spam the messages, please, and please try to focus. As you can see, the second one will become 1/3 plus 1/4. Using the same pattern, 9 over 20 will be 1/4 plus 1 over 5. 11 over 30, 1/5 plus 1 over 6, until 43 over 462, that's 1 over 21 plus 1 over 22. And then after that one, okay, this is the tricky part because I think we haven't distributed that one. So this one na lang, I'll be putting it here. I mean, this one here, I'll be putting 1/2 plus 1/3. We'll be distributing the negative, so that's minus 1/3 minus 1/4, so that you will see what happened, plus 1/4 plus 1/5 plus that, until on the latter part, we have 1 over 20 plus 1 over, 1 over 20 plus 1 over 21 minus 1 over 21 minus 1 over 22, like that. So as you can see, the positive negative 1/3 will cancel out, positive negative 1/4, 1/5, 1 over 20, 1 over 21, and what will be left is just 1/2 minus 1 over 22, which is equivalent to LCM, that's 5 over 11. That's like 10 over 22. It's 11 over 22 minus 1 over 22. That's 10 over 22, or 5 over 11. That's why the answer is 5 over 11. I'm hoping this one is clear. Yeah, that's one. We need to like be familiar with these cases. There's a lot of that kind of scenario, but this is one of those scenarios, actually. The pattern of, there are other cases, so but you need to be familiar with those one. So you need to be familiar that some of the cases like a plus b over, this is the form a plus b over ab, right? It can be expressed to be 1 over a plus 1 over b. So these are the possible cases. So you need to study all of those fractions that we can split. We call it partial fractions. So you can study partial fractions to know those ones. And that is a technique for this one. Okay, then. Try to study partial fractions, we call it.
Okay, thank
Yeah,
you.
welcome. Okay. Yes, any question? Who's that raising hands? No more? Okay, that's it. So partial fractions for this one. Try to learn partial fractions. Okay, yes. Okay, please stop spamming the names again one more time. Again, please try to stop spamming, or else I'll be kicking those that are not behaving properly. It will be reported also, so you might have minus score in the test. You want that one also? All of this are recorded, right? Again, all of these things are recorded, even your messages. So I'm hoping that we will behave on that one. Okay? Oh, no, but yeah. Please do behave. Okay. Let's try to move forward to the next question. How about this one? Yeah, this one is the summation of consecutive numbers. Okay, so we have learned this one. Okay. Yeah, 1/2. Oh, no, blah, blah, blah. Okay. Yeah. Okay, so let's try to have a shorter one for this. This was a bit a longer one, the solution. I want to let you learn the shorter one. It's actually what we call the summation of consecutive numbers. Because as you can see, if you group this one together, we have learned already this one a while ago. This is 1, 1 plus 2, 1 plus 3, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 5, and so on until 1 plus 2 plus 3 until 20. That's the pattern in this question. So we learned a while ago that if we add 1 plus 2 plus 3 plus that until n, that's n times n plus 1 over 2. No? By n plus 1 over 2. That's why it became here. Sorry, n times n plus 1. Sorry from handwriting. N plus 1 divided by 2. Like that. Sorry for handwriting. As you can see, the 1 here became 1 times 2 over 2. The 1 plus 2 became 2 times 3 over 2 by using that formula. Using that formula. Right. Now, yes, you can go, just go. Now, if you look at this one here, until 1 to 20, that's 20 times 21 over 2. So actually, for this case, yeah, we can perform this one, but you have also a solution for this one. Okay, if we have that summation of 1 times 2 over 2 plus 2 times 2 over 2 times 3 over 2, let's try to have a formula for that one. If you can use that one, over 2 plus that until, or let's try to have 3 times 4 over 2 plus that until n times n plus 1 over 2. No? Okay, n times n plus 1 over 2. The summation of that, if we add all of that. So the formula, if you'll be having that equation, will become equivalent to this one here, could be simplified to be n times n plus 1 times n plus 2 all over 6. Okay, let's try to simplify the solution. Okay, that's a formula for that. If you're adding the sum of consecutive numbers, we call it. Okay, so as you can see, n times n plus 1 times n plus 2. Now from that, we can simplify that one. For this case, your n is 20. We're adding until 20. So as you can see, since we're adding until 20, we'll be having the formula 20 times 21 times 22 all over 6. So if you try to solve that one, that will give us 20 times 21 times 22, n times n plus 1 times n plus 2 all over 6. So that will give us, 20 times 21 times 22 all over 6. Yeah, it will give us 1,540. And that's a solution. This shorter one for that. Actually, this one is the derivation. This one is the proof of how, this is actually the proof to how to get in this formula. But if you know the formula, that will become quite faster again. The summation of consecutive numbers. The summation of consecutive numbers are what we call triangular numbers. Because it's what we call triangular numbers for that matter. Any question and clarification for this as we continue to get to the next one? Any question and clarification for this one before you move forward to the next question? Okay, if there's no question, yes, let's try to move forward to the next number. Okay, next number. Let's try to go to question number 15. In summer, reads a book happily. Here it's 83 pages in the first day, 76 and so on. And 2 more than the average of the third. Okay. How many? Yeah, that one. So we know that the average of the first, what we call is 2 times the average of these 5 pages, no? So the average of these 5 pages was actually, how much is the average? That's 304. Okay, wait. 304. Okay, sorry. For this one here, 76, wait lang. Okay, how many pages does read on the 5th day? So actually for that one here, we're trying to find the average first of the first 4 days. So disregarding that one. Okay. 2 more than the average in the first 5 days. So what will we do for this one? How do we solve for that one exactly? So for this case, we are going to subtract this page in the 5th day. 81 on the first day. Okay, 84 on the second day. Why is it logging? My laptop is logging. Wait. Okay, so for this one, Can you see the screen, everyone? Okay, let's try to have this one. So we can find the average of the first 83 plus 76 plus what we call this one. We can use a little bit of an algebra for this. 71 plus what we call this one. Plus the next day will be 64. There's a little bit of an algebra. 64 plus the average. So the fifth day is actually 2 times the average. So let's say the average is x. Okay, so 2x all over 5 is equal to what we call this one, x, like that. Okay. So, or basically we can have that one. A little bit of a block method if you look at that one. We can multiply both sides by 5. So therefore, the sum of everything here, like the sum of everything here, like 71 or 83 plus 76 plus 71 plus 64 will give us 294. So as you can see, we can have times 5 there. We'll be having 294 plus 2 times the average is equal to 5 times the average. So 5, the sum will be like 5 times the average. So therefore, we'll have like 5x or 3x, okay, because 2x, we can subtract 2x here, 2 boxes if you like, by box method. Let's say you can have the x to be the box, right? Box, like that one. You can check that one as to be block method or box method. So 5 boxes minus 2 boxes will give us 3 boxes. So therefore, 3 boxes is equivalent to 294, like that one. And divided 294 by 5, okay, that will become equivalent to 294 divided by 3, I mean. That will give us, what we call this one? 294 divided by 3, that will give us, 98. 98, right? 98. But the question is, how many did he read? 2 more. Oh, sorry. 2 more than. Okay, I'm so sorry for that one. It's 2 more than, not twice. Okay, I'm so sorry for that. That's 2 more than, that's not twice. Okay, 2 more than. Yes, plus 2, not 2 times. Sorry, I didn't read it properly. So it's 2 more than. Okay, so that's x plus 2. Sorry, not 2x. Okay, so x plus 2. So that's what we're going to happen for that. And because of that, we can find the given. So x plus 2 for this. So that's not 2x. X plus 2 or box plus 2. Okay, box plus 2 for that. Box plus 2. So 5x. Let's try to have that one. Finish that one out. Okay, so x plus 2 here. Okay, or that's 296 now. 296 plus x is equal to 5x because of that. And then by transposition, 4x is equal to 296 or 4 boxes. Therefore, x will become equivalent to 74. Wait lang, 76, sorry. 2636, I'm so sorry. Okay, the extra one will become 1628. That will become the answer. How many? 74 is x, so therefore plus 2, x plus 2, the one on this 5th day will become 76 because the x plus 2 is the number of books he will be reading on the 5th day. So the correct answer for this question is actually 76. Any question and clarification? Any question and clarification will for this question before we move forward to the next one? Okay. If there's no question, okay, let's try to move forward to the next number. Question number 16. Let's try to go to question number 16. How about this one? So question number 16 states that if we had a number in the numerator and minus the same number in the denominator, on the fraction, the new fraction will be simplified to be 7/8. So, okay, this one is a little bit of a guess and check. for this situation. So what they did is guess and check. Find this number. But for this situation, you can do guess and check method, but I'll be showing you some algebra method for this. Because again, we'll be having, or we're going to, oh yeah, guess and check. One of the ways is guess and check. So we can add, we can do like add it, but it will be taking us so long. So the shortest way is actually we can have the algebra. No ways we can extend the time. Okay, we'll try to finish everything. If you want to stay behind after the clock, you can stay behind if you want to finish it together with us. If you cannot, then it's okay now. We can extend actually for this. Okay, to discuss to you the lessons here. We can extend. No worries for that one. If you want to stay behind, you can stay behind and learn. If you will not, then the video will be sent to you also later on for that case. Okay, we'll try to finish this one out. Let's try to move forward to the next question. And we'll be having a little bit faster than for this. So 43, we add a number in the numerator, so 43 plus x, and we'll be adding minus in the same numbers in the denominator. So 77 minus x. Again, Mr. Leroy, please not, if you don't ask, please don't annotate here. So 7/8. So for this one, we can do cross multiplication. Again, you can stay behind, or if you want to go, you can go. Okay, by 11. Okay, by 11. It will be your choice. It will be your choice. Yes, if you want to learn, then you can learn. Again, please use the chat box as responsibly as we could. Just try to use it for inquiries only. Okay. And then proper inquiries to the question so that we will not be delayed. So we'll try to have this one. Let's try to do cross multiplication. Again, Leroy, please try to stop annotating. Okay. Try to move forward. Cross multiplication for this. So 43 times 8, that will give us 24. 400. 4 plus 8x. Wait. 32. Sorry. 32. 24, that's 340. Wait. 43 times 8 by cross multiplication. So 43 times 8. That will give us 344 plus 8x, using that one. 384 or 344 plus 8x is equal to what we'll be having, 7 times 77. Okay, minus 7x. Okay, 7 times 77. 7 times 77 minus 8x. So that will give us 539. 539 plus or minus 7x. So algebraically speaking, we can add both sides by 7x, like that, and then subtract it by 344 minus 344, like that. So for that case, what will happen is that you'll be having 15x is equal to 5, 9, so that's 195. So 15 divided by 195, that will give us 13. So the correct answer for this question is actually 13. And yeah, that's the correct answer. So your x is equal to 13 by dividing it by 595. Any question and clarification for that one, everyone? Are we clear so far with this? Before we move forward to our next one. So the correct answer should be 13. Yes, Nathan? Yeah. Let's try to move forward to the next number. Again, it depends upon your speed actually for this question. Wait, again, please try to focus on what we have been learning here. If you will not be having that one, may I request everyone to try to focus for this question. Let's try to move forward to the next one. It depends actually for your level. If we are quite fast for this one, we are fast. We can finish it fast. But sometimes there will be a lot of questions from this question, so that's why we're answering those. And again, the solutions are, if you want me to just give short answers, can you understand it already? May I ask? Mr. Nathan? Is it okay na for that one? Can you finish the questions and just a 1-minute discussion? Can you do that one? Okay, so again, if we can understand it in just as fast as we could, we can have it here, then we'll have it. If you want to listen again, you can listen. If you not, then you can go. Okay? So for that one, let's try to move forward. For those who are here and then appreciating the discussion, that's quite good. Okay, let's try to move forward to the next question here. There are 3 consecutive natural numbers. The first one is a multiple of 5. The second one is a multiple of 7. The third one is a multiple of 9. Find the minimum value of the smallest natural number. Okay, the 3 consecutive natural number, the first one is a multiple of 5. The second one is a multiple of 7. The third one is a multiple of 5. Find this minimum value of the smallest natural number. So for this question here, yes. Okay, find the minimum value of the smallest natural numbers for this question. So how do we try to find that one? Again, consecutive. So as you can see, it's a little bit of a guess and check for this one. So we have 20, 21, and 22 is not a possible because the third should be a multiple of 9, right? The third is a multiple of 9. So how do we find the smallest number that will satisfy this scenario or given here? So first things first, we have already 20 and 21. That is what we call this one. 20 and 21 to be the possible case for that one. Okay, so as you can see, for the case of the 22, we'll be having for the case of 22, the smallest number so far is 2021. That will have a multiple of 5 and 7 right away. That is in between. But the 22 is not divisible yet. So if you divide 22 by 9, it will give us 22 divided by 9. That will give us 2 remainder 4, 2.4444, so on. That's remainder 4 to be exact. Okay, 2 remainder 4 for that case. So we wanted for it to be divisible by 9. Okay, for it to be divisible by 9. So to solve for that one, we need to identify, because after that one, we need to find the first number that will give us already that situation. Now we can go with the next possible number, 35. Why did we have 35? So because we have 35 and 36 next. So 35 and 36 is those two numbers, that multiple of 7 and multiple of 9 right away. Now, but before that one, that's not divisible. That's 34, right? 34. So basically from that, we will try to find out the next number that we can have so that the next number will be divisible by 7, having the same momentum or the same situation for that. Okay, so for this one, it's a little bit of a modulo process actually, a little bit higher process from your level, but I'm hoping that you will be understanding the modulo already for that. Okay, because we're trying to get those numbers that the next number will be divisible by 7. So we'll try to preserve the situation. So we have 20 and 21. That's remainder 1. So the remainders for that case is 4 for 22. And for the case of the 35, because we wanted to have it at 9, your 35, the remainder is actually 8. That's 3 remainder 8. The next one is 3 remainder 8. So we'll try to continue with that one until we had 25. We preserved, wait, 22, 13, 23, 35. Wait. So we try to find the numbers there that we can preserve until that the last number will be situation that will have what we call this one, that will create a situation where the next number will be divisible by 9. So we choose a 36. As you can see, that 35 will give us a remainder of 8. So as we continue, we can have 35 times 4. It will give us 140. Okay, preserving the 7 and the the 9 remainder plus 20, that initial number that satisfy us. So that will give us 160. So because of that 160, if you will check, 160, 161, and 162 are divisible. This one is divisible by 7. This one is divisible by 9. This one is divisible by 5. So these are the first three natural numbers, that three consecutive numbers that will be divisible by 9. I mean 5, 7, and 9. That will become the answer for number 17. Okay. Again, if you want to go ahead, you can go ahead by 11. If you do, those who wanted to stay and continue learning with this lesson, we can stay behind and learn the lesson. Okay, so that will become the answer for that one. If that's the case, so try to move forward with the next one. Okay, question number 18. Question number 18. Teacher writes 23 natural numbers on the blackboard and lets Ming to calculate the average to keep a decimal place. Ming calculates 12.61. Teacher said the last number is wrong. Other numbers are correct. What is the correct answer? Again, teacher writes 23 natural numbers and lets Ming to calculate the average to keep us to decimal place. Okay, those who are reviewing, because not all are reviewing for the final round, maybe final round review, what we call this one, we'll try to have the mock test. Or again, for those who wanted to stay, you can stay behind by 11. Those who wanted to go, you can go. Okay, but again, for those who wanted to continue listening here, you can stay behind. So again, teacher writes 23 natural numbers on the blackboard and let Ming to calculate the average to keep us 2 decimal places. Ming calculates 12.61. Teacher said the last number is wrong. The other numbers are correct. So if we have to have that one, you have 23. We can use 12.6 to be 23. 23 times 12.6, it will give us approximately 289.9. So if you'll try to use the numbers, the sum of the numbers here is, we'll try to go forward, because if you go backward to be 289, that's less than 12.60. So we'll be like guess and checking 290 times 23, that will give us 12.61. So 291 times 23, that's 12.65 already. And 292 divided by 23, that's 12.70. So again, it's correct, the 12.6 part. So the last number is wrong. We don't know exactly what's the last number. So approximately, we can use the 12.6 to find the sum, because 12.6 times 23 is the sum, basically, of those 23 natural numbers. But we cannot have what we call this one. We cannot have exactly 12.6. So we can just approximate the next number, sum, 290. That's 12.61. This is not what we'll be doing, because that said it's wrong. Therefore, we can check 291 as the sum of the numbers, so divided by 23. That will give us 12.65. Then if we go to 292, that's 12.7 already. So it will not, the 12.6 is correct. So we'll try to take on the 12.65. So the correct answer for this question is actually 12.65. Any question and clarification for that one before we move forward to the next number? Approximate sign. I think that's not, yeah, approximation sign, yes. Okay, but that's what they use in the sign. So we can use approximation sign if you have, but by analysis, that's an approximation only for that. Okay, so approximation sign, you can use that one as an approximation sign. Okay, question, clarification? Yes, Kaden? Any question?
Mister, I don't understand the way how they find the number.
Again, for that one more time. The three numbers, the last number is wrong. So the 1 is wrong. So meaning 12.6 is the correct answer. So again, how do we solve for the sum, right? So we know to calculate the average. Average is equal to sum divided by the number of terms, or how many numbers are there. Okay, how many are there? So that's like n. So as you can see, we don't know the sum, right? We're trying to find the sum. So but we know that the correct average is 12.6. something because we'll be rounding it off to 2 decimal places. So what will we do right now is to try to find the sum of the 23 digits, and that will become equivalent to the average times n, like that. So we'll try to use 12.6 first and multiply it to 23 numbers because we do know that your n is the number of numbers. How many are there? That's 23. So 12.6 times 23, that will give us 289.9. 289.9 for that case. Now, since it's 289.9, we can basically now get what we call this one. That is the approximate sum. But take note, natural numbers are whole numbers. Or no, yeah, whole numbers. There's no decimal for it. So we'll try to approximate the next sum that is possible, which is 290. So if you divide 290 by 23 and round it off to 2 decimal places, that will give us 12.61. And it says already that 12.61 is wrong because 1 is not the correct last number. So we add 1 more because we can go with the 291 as the next possible sum. So 291 divided by 23, that's 12.65. Maybe that's correct, but we can check, add 1 more sum. 292 divided by 23, that's 12.70 already. And this is wrong because we know that the 12.6 part is already correct. So 12.7 is wrong because we cannot have 7 in the 10th digit. So therefore, the only possible choice, the sum is 291 and the average is 12.65. And that's the correct answer for that. Understand?
Okay, thank you, sir.
Welcome for that one. Now, if it's understood, again, let's try to move forward to the next one. This is number 18. Number 20. Let's try to go with number 20. For this case, number 20. Let's say number 8, number 19. Next question. For first 500 natural numbers, how many numbers without digit 5 are there? Without digit 5 are there. So for this one, the best way to solve for this one is actually how many natural numbers without digit 5 are there for the first 500 natural number. So how do we solve for that one without digit 5? So basically for this one, we're going to know first a little bit of a combinatorics. 5 times 9 times 9 minus 1. How did it happen? Because again, we're trying to find how many natural numbers without digit 5. So we'll try to count here from 500, first 500 natural numbers. Take note, the first 500 natural numbers are 1 to 500. So among those numbers, the question is, how many don't have a digit 5 in their answer? How many does not have digit 5? So how do we solve for that one? Okay. How do we solve for that one? So again, we'll try to count first 1, 2, and so on. We'll try to count the numbers that have a digit of 5 in their given, and we'll subtract that 1 for those numbers that don't have digit of 5. So for this one, basically for this one, we can assume that we'll use a 0 for that matter. Okay, for us to be fast for this one, we'll try to use 0 or we'll try to use the first 500 natural numbers to be 3-digit number, having the tens, the ones, the hundreds, and the ones, right? The ones place. Then we'll try to subtract later on those numbers that we cannot use for the first digit, okay? So as you can see, the 500, the double checking without digit 5. So as you can see, we cannot use a digit 5. So because of that, basically, in the hundreds place, we can use 9 numbers here in the hundreds place, okay? Because you can use either 0 to 9 except for 5. Okay, I will be using some combinatorics. Here in the thousands, hundreds digit, we can use 9 numbers only also, because you cannot use 0 to what we call this one, 0 to 9 except for 5. So we can use, there are 10 digits, but we cannot use 5 for each of the hundreds place in the hundreds and then the ones place, like that one. Hundreds in the ones place. Okay, sorry. Move for that one. Now, For the case of the tens, hundreds, tens, and ones. Okay, this is hundreds, this is the tens, and then the ones place. So for the case of the hundreds place, because 500 natural number, we can only use 5 numbers here. What are those 5 numbers? We can use 0, 1, 2, 3, 4, like that. Okay, so if you look at that one, we have 5 digits for the hundreds place. 0, 1, 2, 3, 4. No, sorry. There should be like 1, 2, 3, 4. Like that one. 1, 2, 3, 4, like that. So technically, you'll be having like five ways. 1, 2, 3, 4, 5 actually, no, including the 5 for that case. But here, for the case of the last digit, or the tens digit here, they'll be having like 4 times 9, 9 ways only, except for 5. So 5 times 9 times 9, that will give us, what's the answer for that? 5 times 9 times 9, that will give us 405. Okay, so there are 405 numbers actually that has digit of 5, that has no digit of 5, except for one of the last number there is 500. So minus 1 will give us 5, or that will give us 404. Actually, will give us 404. So the answer for this question is actually 404 for that case. Okay, one way to visualize that one also, the other way is that we can actually try to count the numbers that have a digit of 5. Example, if it's 1 digit, okay, because 1 to 100. For the 1 digit, we have only one number that is divisible by, that has a digit of 5, which is 5. Okay, the 5. Okay, like that one. We can do this way, 5. Okay, now for the case of the 2-digit numbers, we do have actually, if you'll try to count that one, we do have starting from, or let's say per 100. Yes, Kaden? Any question?
Mister, for
Yeah.
at the hundreds place, why it says that there are 5 ways, right? But why does it includes 5 in it?
It's include 5. 1, 2, 3, 4, 5. Because we cannot have 0 in the hundreds place for that case. 1, 2, 3, 4, 5. It means that you'll be
But I thought 5 cannot be included.
Yes, that's why we subtracted it by 1. Oh, yeah,
Yeah.
that's a very good. Okay, but 500, 400, 0. Wait. Yeah, that will become a little bit tricky. Okay, kind of tricky for this one. Yes, it could be 0 for that one. So I think the better solution will be like this one. Let's try to confirm the solution for that, because it's a little bit of a tricky one. I think the better solution is this one. Okay, we'll try to count the numbers that have 5 and subtract it from 500. I think that's a better way to count that one. Example, that's how we do that one. So if you look at that one in from 1 to 99, like that, we'll try to count how many numbers has 5, no? From 1 to 99. So if you look at that one, we have like natural numbers means starting with 1, 1. Okay, so 1 to 99, how many numbers has numbers is divisible by 5, right? How many numbers are has a 5? So we have like 5, no? 5, 15, 20, 5, 35. I'll write it this way as a technique. 45, 55, 65, 75. I think it should be a better way to have this one, approach it this way. So that it will be quite clear, right? 100 space. So I think it's a better one here. Okay, so as you can see, 5, 5, 5, 75, 85, 95. Okay, right. In 1 to 99 only, right? Now, then in the 50 numbers, 50, 51, 52, 53, 54, 55, 56, 57, 58. Sorry for my handwriting, 59. So as you can see in 1 to 100, these are the numbers. 1 to 99, I mean, these are the numbers that have 5, right? So if you count that one, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 20. But we double counted the 55, so we know that's 19. There's 19 of them, right? In that situation, 19, right? 19. Do we follow for that one so far, everyone? Yeah, 50, 19. Okay, so there are 19 from that. So 19 per 1 to 100, actually, there are 19 numbers that has 5. So from 1 to 99, we have 19, right? So we can say also, okay, let's try to move this one here. Okay, so that you will see it further. So if you look at that one, there are 19 for the digits from 1 to 99. So there will be 19 also. If you'll try to look at that one, oh, if I'll add 100 something, there will be 19 from 1 to 99. There will be 19 from 100 to 199. There will be 19 from 200 to 299. There will be 19 from 300 to 399. And there will be 19 from 400 to 499, right? Like that one. So as you can see, 1, 2, 3, 4, 5. There will be like 19 times 5 numbers, 19 times 5, because there are 5 set. Each of this set will have 19 that has number 5 digits. So 19 times 5, that will give us 5 carry 4, that's 95, right? So basically from 1 to 499, okay, or 1 to 500, there's 95. Actually, 96 if we include the 500, because the 500 has 5. So from 1 to 500, there's 96. So that's 500 minus 96. That will give us 404. Yeah, same, different solution, but same answer. But this is actually the more concrete one, because you will see that there are actually 404 there. And that's the answer to our question, 404. Any question with clarification with that one, everyone? How did we get to 404? Before we move forward to the next one. Okay, so if there's no question for that one, let's try to move forward with the next number. Okay, let's try to go with number 20. Okay, let's try to go with number 20 as much as possible. Okay, number 20, number 20. Wait, why is it that it's logging? Let's try to move forward to number 20 for this one. Okay, number 20. How many consecutive?
Mister,
Yes.
can I take a picture of the writings before in number 19 again?
Yeah, can you go back with the video? Okay, because we also okay, let's try to make it fast. Okay, make it fast. Okay, ready? One, 2, 3, 4. Can you see it now? Can you see it now? Make it
No,
fast.
Mister.
How about now? Can you see the
Yes.
writings? Okay,
Okay, thank you.
welcome. Okay, let's try to move forward to question number 20 for this one. Question number 20. Okay, so here, how many consecutive zeros are there in the unit digit to the left, right, for this one? So how many trailing zeros actually for this question? So this is actually what we call 500 factorial. So to solve the number of trailing zeros, basically what will we do is actually we divide it by 5. Okay, so this is the process. So the solution, this is what we call a little bit of an algorithm. So if you want to know the number of zeros at the last part of 500 factorial or n factorial, you just divide it by 5. Okay, so we try to start with the 500 divided by 5, that's 100. So that's 100 numbers divisible by 5. Then 100 divided by 5, that's 20. 20 number divisible by 25. Okay, this one is another 100 number divisible by 5. And then 25 divided by 4, that's 100 number divisible by 125. So each of these factors, this is actually 100 factors of 5 so 25, and 104 factors of 5 in 125. Okay, we stop there because we cannot divide it anymore by 5. Okay, so here we add those answers. 120 plus 4 will give us 124, meaning there are 124 factors of 5 there. And each factors of 5, if you pair it with 2, it will become 10. Therefore, each of those 10 will create the 0 in the last part. Therefore, the answer for this question is 124. Question and clarification for this. Yes, there are videos that will be sent here. Yes. Any question with that one? Clarification, everyone? Okay, if there's no question, let's try to move forward with the next one. Okay, question number 21. Okay, let's try. That's the algorithm for number of trading zeros for n factorial. So let's try to go with number 21. Okay, what's happening? 21. Between 200 and 250, find two integers such that if their product is equal to the product between 143 and 323. Okay, so so to solve for this one, we'll try to do prime factorization for that one. Actually, try to regroup only. Because 143 is 11 times 13 and 323 is 17 times 19. We can regroup this. Okay, so actually we can have and try to find two numbers that will create that one. So as you can see, if you try to have 11 times 19, that's 209. And 13 times 17, that will give us 221. So these numbers are in between 200. So it's a little bit of rearrangement of the factors. So as you can see, the numbers are 209 and 221. The sum of these two numbers is 430. And that's the answer for 429. Again, for number 21, 11 times 19 is 209. 13 times 17 is 221. So therefore, those are the two numbers, and that will become equivalent to 430. Their sum is 430. Okay, hoping this one is a little bit easy. Any question for that? Okay, question, clarification? Because if there's none, let's try to move forward to question number, let's try to finish that one up. Question number 22. Question number 22 here. Okay, a little bit the same for the previous number. Okay. Okay. Actually, for this one, number 22, basically the same.
Mister, can
Yes.
can you come back to question 21? I did take a photo.
Yeah, no worries. Try to see the video later on. Okay, there you go. Take a photo, please. 1, 2, 3, done. Yeah,
Oh, wait.
it'll be emailed. Okay, but as you can see, no need to take a photo because it will be sent. The pictures will be sent to you later on. Okay. All right. The pictures will be sent to you later on. Okay, let's try to move. The videos, I mean. Okay, let's try to move forward with number 22. This one is a little bit similar to one of our question a while ago. For this one, if you minus a number on the numerator and add the same number, right? It's a little bit similar. 55 minus x all over 64 minus x. Okay, like that one. The new fraction is 4 over 13. So we did cross multiplication a while ago and eventually get the correct answer for that one. You can do guess and check for that one if you like. Okay, but again, it's actually better for us to deal with this as what we call this one. As a fraction, or as much as possible, we try to deal with this one as algebra. So we can do again cross multiplication. And after we do the cross multiplication, we'll be having 55 times 13. No, this is plus in the denominator, right? Plus. We'll be adding the same number in the denominator. So as you can see, you'll be having 55 times 4, or 55 times 13. That will give us 700. This is a cross multiplication process. 715 minus 13x is equal to 4 times 64. Okay, so 4 times 64, that will give us 256 plus 4x. So we did try to cross multiply. So 700 or minus both sides by 256. Minus 256, minus 256, and add 13x, like that algebraically. So we'll be having like 17x is equal to 715 minus 256, and that will be giving us 459, right? 459. So if you divide 459 by 17, your x will become, dividing it by 17, 17. 459 divided by 17, it will give us 459 divided by 17. Okay, wait lang. 459 divided by 17, that will become 27. So the correct answer for this question is actually 27. Any question and clarification with that one, everyone? Can you hear me? Okay, question clarification for this as we move forward to the next one. Okay. Please stop spamming the messages. Okay, if there's no question, let's try to move forward to the next number. Okay. Oh, again, this one is a little bit similar to the question number 11 a while ago, or one of the question a while ago. But actually for this one, okay, let's try to have it a little bit of algebra because like it's a very big number. Okay, we can apply a little bit of an algebra here for you so that you will see another solution for that. Because it's like similar to the previous one. Your 2013 is like, we can express that one to be x plus 2. Okay, then here, your 2011 can be expressed as what? 20, that's like y. Let's try to express that one to be y. Minus, this is x. The 2011 will become x because 2013 is x plus 2. So it will become easier for us to see. And the 2012 is like y plus 1000. Wait, how many did we add? Yeah, 1, 0, 0, 0, 1. That's 10,001. Because your y is 1011. 2011, like that one. We can express that way. So that will become easier in algebraically. So by transposition or distribution, you'll have like xy plus 2y. We distribute your x or your y here. Minus, we distribute the y here. That's xy minus 1001 or 10,001 x, like that. 10,001 x. So as you can see, we can actually simplify, or xy minus xy will cancel out. So you'll have like 2y, 2 times 2y minus what we call this one, 1001 or 10,001 x. That will be left. But what is y? Your y is basically 2 times 2011. No. 2 times 2011, 2011. And your x will be 2011. Like that one. 1001 times 2011. Like that one. So as you can see here, if you try to multiply, this is like 4022, 4022 times 2 minus 2011, 2011. If you multiply 1000 with 2011. And as you can see, if you subtract this one, this will be going back to be 2011, 2011. And that will become the answer to our question here. 2011, 2011. Any question with that one? It's like a little bit easier if you do it in algebra. Yes, again, please stop chatting there. Yes, it will be sent to you, the videos. No worries for that one. Okay, I am not the one be sending, it's the PBB. Okay, so let's try to move forward to the next number. Okay, let's try to move forward to the next number. Question number 24. Okay, how about this one? Okay. Yes, here. Kindly mute yourselves. Okay, let's try to move forward to the number 24. Okay, how do we solve for this question exactly? Why is my laptop is logging? Okay, great. Okay, so for this one, actually, this is like a little bit of another partial fraction that we had a while ago. So, but we need to like be familiar with this one. As you can see, this is a product of 3 numbers, right? So we can break this one out to be, if we have that one on top, we have on top you have actually the what we call this one. a sum on top of, we have like 1 over A times B times C, like that one. We can break that one out to be 1 over A, or 1 over C minus A, like that, times 1 over A times B minus 1 over B times C. That is the formula for that one, or another partial product. So as you can see here, let's try to show this one here. Okay. Again, 1 over A times B times C is equivalent to 1 over C minus A, the biggest minus smallest. So let's try to show that one here in the 5 over, we can factor out the 5. So that's like 5 times 1 over 1 times 3 times 6. So if you look at that one, we'll be having 5 times 1 over 6 minus 1. The difference between the highest and the smallest. So that's 1 times 1/5. That will become 1 times 1 over 1 times 3. The first numbers, AB, minus 1 over 3 times 6. Like that one. Okay, let's try to move it a little bit there on this side. So as you can see here, we'll be having 1 over 3 times 6. So as you can see, this will cancel out each other, and what will be left for this whole expression is 1 over 1 times 3 minus 1 over 3 times 6, like that. So all of them will follow the partial fraction also. That's why the next one will become 1 over 3 times 6 minus 1 over 6 times 8, so on and so forth. And again here, we can cancel out the plus, minus, and everything will be left is 1 over 1 times 3, or 1/3, minus 1 over 48 times 51. And eventually, you can use fractions. Simplify natin, LCM, or we'll try to simplify LCM. So the first one will be multiplied by 16 times 51. The 1/3 is like 16 times 51 over that. This is the 1/3 minus 1 over 48 times 51. So that's actually simplifying. That's 815 over 248. So another partial fraction problem, similar to this one. Please stop spamming that one. Please stop that. Any question with that one? Clarification, everyone. So that will become the correct answer. Another partial fraction problem for this number. Okay. All right. If there's no question for that one, let's try to move forward with the next problem. So another partial fraction problem. Try to move forward to question number 25. Observing the questions below, 5 plus 3, 7 plus 6, and etc. What is the sum of the 2028 equation? I think there's a missing here. I think there's a missing, for number 25, there's a missing given. For number 25, I can see. Wait lang, let me double check. I think I haven't double checked the number 25. The pattern is missing for the number 25. So we cannot, yeah, there's a missing pattern for this one. I think we can skip the number 25 because the given is a little bit not complete. Okay, so we will be skipping that one first. Number 25. Let's try to go with number 26, the invalid question. The given is like missing for that one. Okay. Number 26, this one. Okay. 0.89 times 5 plus 0.88 times 5 plus 0. And so on. Find the integral part. So how do we solve for this one actually? Okay, so for this, what will we do is just we'll try to factor out the 5. So as you can see, you have 5 times 0.89, 0.81, and so on. Okay, then we can try to find the sum of these numbers. Okay, again, these are consecutive numbers. If we'll try to check, that's like the sum from 0.89, 0.81 until 0.89, right? So again, we have the formula for that one already a while ago. If you'll try to count that one, those are 9 numbers because from 1 to 9. So if you remember, again, we have the formula for the summation of consecutive numbers. The sum a while ago will be the sum of the first plus the last times how many numbers are there divided by 2. So for that case, that will become equivalent to 0.81 plus 0.89 If we combine them, if we pair them up, times how many numbers? That's 9 divided by 2. That's the simplest way to add this one up. And if we do that one, that will give us 7.67. And then 5 times 7.67 will give us 38.25. So the integral part is equal to 38.25. Any question for that one? Verification. Are we clear with that one, everyone? Why is it that there's a lot of chat that is not related to our discussion? Please. Okay, this is the first time that I handle this kind of group, okay? So I'm hoping that we are still focused on this discussion. Let's try to have, again, any question for this one? Clarification? Because if there's none, let's try to move forward to the next number. We'll try to go to question number 27. In the given figure, the length of the square is 3. 3 squares are 2. Find the sum of all the shaded area of this square. So for this one, actually, what will we do for that one? We use pi to be 3.14. If you try to visualize this one, each of them is actually, we can redraw it, and that's like a circle. The shaded region is like there's a circle, or the shaded region is like the square minus the circle part. Because as you can see, if you try to rearrange them, we can create a figure like that. A square, then the shaded region will become the circle outside, like that one. So it's like basically the square minus the circle's area, then times 3. Because there are 3 parts for that one. That's the easier way to solve for this. Again, if you visualize it, we can create a circle inside, just reversing the, because it's like quarter circle minus the smaller square. So if we rearrange that one again, it will be making a big square minus a big circle. So the square with a side length of 3, side length of 2. So the area of the square is 4 minus, because of that one, side length of 2, the radius of the circle right now here is 1 unit. So that's why 4 minus pi. Kasi the area of the circle is pi times r squared. And your radius is what? So that's pi, or 3.14. So that's like 4 minus 3.14 times 3 only. So that's like what? 0.86 times 3, and that will give us what? 18 carry 1 to 2.58. The correct answer for number 27 is actually 2.58 units for this one. 2.58. Yeah, that's how simply we can get the number 27. Any question with that one? Clarification. This is like visualization only if you try to analyze it. And that's the answer for number 27. Okay, if there's no question for that one, let's try to move forward to question number 28. 28. Okay. Question number 28. There is a mathematical Olympiad book with 219 pages. To code the page number from 1 to 231, how many digits are needed to code the page numbers? Wait, to code page numbers from 1 to 231, how many code are the page numbers? Wait now. Mathematical Olympiad book with 219 pages. To code up the page numbers from 1 to 231, how many digits are needed for the page number? So okay, that says, okay, so that will become 585. How did we solve for that one? So basically we'll be counting how many numbers are there, or 1 digit. So there are actually 9 1-digit numbers, right? This is the 1 digits. How many 1 digit? There are 9 1 digit. There are 92 digit numbers. So 90 times 2, that will give us that's like, again, 9 1-digit number. So 1 times 9, because like 1 digit lang yung 9 digit numbers, or the 9 1-digit numbers. Then you have like 92 digits, so 90 times 2. Then you have 132 3-digit. How did we get that one? So we know that we know that from 1 to 99, 1 to 9, there's 9. Then we have 10 to 99, that's 90 numbers. Okay, then that's 99 already. So 231 minus 99, that's 132. So there are 132 three-digit numbers. So multiply 132 by 3, that's 396 digit for 3-digit, 180 for 2-digit, and 9 one-digit digits. So therefore, adding them up will give us 585 for number 28. Yes, that's the correct answer for that one. We don't use the whole 219. Okay, only 1 to 231. Okay, and that's the answer for that case, 585. Okay, if there's no question for that, okay, let's try to move forward to question number 29. Okay, almost done, everyone. Now the time is 9 a.m. How many minutes are needed to at least such that the minute hand and the hour hand will form 180 degrees? Okay, so how many are needed at least such minute hand? Okay, so for this question, okay, let's try to solve it with the way that I know how to solve it. There's a formula for the degree. Now, 180 degrees is the target, right? So at 9 a.m. So the formula for the angle form with the minute hand and the hour hand, what I know the formula is that we have absolute value of 60h minus 11m divided by 2. That's a formula for that one. I want you to learn that one as early as this. 60 times the hours minus 11 times the minute divided by 2. So to solve for that one, we know that the R right now is 9. The target angle is 180. So 180 is equal to 60 times 9 minus 11m divided by 2. Okay. Now, for those who don't know the absolute value, the meaning of that one is there are two cases. So either 60h minus 11m divided by 2, or the other case is 11m minus 60h divided by 2. That's the meaning of the absolute value, by the way. So we'll try to use that one as the cases so that we will know what's the earliest time. So 180 times 2, that's 360, is equal to first case, 540 minus 11m. 11m like that. So transposition, that will become like 11m is equal to 280. And then if we divide 280 by 11, that will give us 280 by 11. That will give us, let me check, 280 by 11. That will give us 25, and so the minute is at 25 and 280, 45 over 11. That's like 4.545. That's, wait lang. Yeah, that's like, wait. That's 25 and, wait lang, wait. 25 and 5 over 11. 25 and 5 over 11. Okay, 25 and 5 over 11, like that. So that's the first minute possible hand. Okay, but as you can see, that's like less than 30 minutes. Because usually you will think, oh, maybe it's around 9:30. But we'll try to check the other case, because the other case will tell us that the value is 11m. So 11m minus 60 times 90. Other formula times 9, because it's 9 o'clock, divided by 2 is equal to 180 degrees. So times 2, that's 11m minus 540 is equal to 360. As you can see, you will notice it's quite bigger, because 11m will become equivalent to 900. Okay, 11m is equal to 900, and 900 divided by 11, that's equivalent to 900 divided by 11. That will give us equivalent to 81 minutes. That's already 81 minutes. So that's past 10 o'clock, or that's past 9 o'clock. So that's 11 and 9 over 11 minutes. So that's already past 9. That's 10 already. So therefore, the correct answer for this question is at how many minutes? The question is how many minutes, right? how many minutes are needed? So that's 25 and 5 over 11. 25. They use 180. Okay, they use 90 degrees for that one. It should be 180 for that case. That should be 25 and 5 over 11 as the answer for that one. Any question and clarification for that, everyone? 5, wait lang. Did I subtract it properly? 540 minus 360, double checking. I'm so sorry. Sorry. That should be 180, not 280. That's why I got it wrong. Okay, sorry. Should be 180 for that case. That's not 280. So that should be 180 over 11. And that's equivalent to, that's correct, because it will be dividing 180 by 11 pala. That's 16. That's 16 and 4 over 11. I'm so sorry for that. Okay, I think I got it wrong with my mental math subtraction. There should be 16 and 4 over 11. Okay, and if that's the case, we try to move forward with the next question. Question number 30, right? Question number 30 for that one. Last and final question. Okay, for this one, we have, refer to the figure below. Triangle ABC, triangle BDR, isosceles right triangle. The hypotenuse are 20 centimeter and 12 centimeter. Okay, find the area of the triangle. The hypotenuse DC, and then actually the sides. The hypotenuse is like the sides or the legs, right? So that's why, because of that, your DC will become 8. We know BD is 12 because that's your legs. We know that the AB is 20, like that one, 20. So we're trying to find the length of EF, or we're trying to find the area of this quadrilateral. So to solve for that one, basically what will we do is we find actually the area of the triangle BDE minus the area of the triangle EFG. So if this is 8, this will become 8 also, and this will become 4, right? So this triangle here is like half of a square having the diagonal of 4. So to find the area for this, we can use 1/2 the area for the triangle using the diagonal because it's like a square. And it will disconnect it. Okay, so we'll try to have the last one. We'll try to finish this one up. Okay, so for the last one there, as you can see, we'll be having the area of, again, we'll try to have the dimension. Let's try to finish the dimensions for this one. Okay, so for this one here, everyone, as you can see, the length of this one is 8 because BC, the side of the square, is 20. All right, I mean, this one will become 8 is the DC. Okay, this will become 12 because the length of the legs is 20. This is 20 here for AB. Now, because of that, this one will be forming also isosceles triangles. We'll be using similar triangles here. So this will become 8. And because of that, your EF will become 4. So consider this triangle having that's an isosceles triangle with the length of 4, like that. So the formula for this is like half of the square, right? It's like half of a square. So that one, using that formula, we can find the area of the square, or using that one, the area of the square for this is actually 1/2 times, or that's like diagonal squared, diagonal squared. Diagonal times diagonal over 2. So because the triangle is half of that square, we'll be dividing it again by 2 actually, like that. So as you can see, that half triangle, isosceles triangle, could be solved to be d squared over 4, like that. So the diagonal of that one is 4. So like 4 squared, 16, divided by 4, that will give us 4 square units. So the area of this GFH is 4, EFG is 4. That's why we have 4 here. And the area, using the same formula, no? The area of the triangle will become 12 times 12 divided by 4. So 12 times 12 divided by 4, that's 72. The area of this triangle here, the 8 by 8 part, having the diagonal, no, it's not 8 by 8. It's like a 12 times 12 because the legs is 12 and 12. So 12 times 12 divided by 2, the area is 72 for the triangle, minus the 4 on top. So therefore, the shaded region is 68. And the correct answer, yay, is 68. We're done with that one. And that's the answer for that number 20. I'm hoping that is understood. Yes, Larry? Any question? And that's the answer for that one. question and clarification for this number, everyone? Because if there's none, I think that will be it for the meantime for today. Hoping that you learned something from me and you can use those learnings. Yes, yeah. Yeah, the questions are quite hard at this level. Am I right? Compared to what you have. Right. So that's why we're learning this one. And I hope that I imparted to you the solution and the shortcut for these questions. I think that will be it for the meantime for today. At least you learn, right? You're quite not learning. You don't want to
Excuse me?
learn. Yes?
Can you go back to question 24? I need to take a picture of it.
Okay. Try to have it. The video will be set. And you have also the solution set given with you right now after this one. Okay? I think that will be it for
Okay.
the meantime for today. Have a good day, everyone. Bye-bye. Hoping that you learned something and you can use that one in the competition. Bye-bye. Welcome. Bye-bye. Welcome. Bye-bye. Bye-bye.
Goodbye.
Bye, everyone.
Thank you, Mister. Bye, Mister.
Bye-bye.
Bye.
Yes, I did. Bye-bye.